Hello, everyone. Welcome to the Math Magician's Den. We are going to talk today about limits that involve trigonometry. Trig. Everybody loves trig. And there are three basic ones that get us through a lot of problems. Number one is the function sine of x over x. What we're going to do first is we're going to take a look at this function and we're going to talk about what's the limit as x approaches 0 for sine of x over x. Now you notice if we plug in 0, we're going to get sine of 0 over 0, which comes out to be 0 over 0. That's an indeterminate form. And indeterminate forms are basically this. Obviously, we plugged in the number and we can't find the limit, but that does not mean I can't find the limit another way. So what we're going to do is we're going to take a look at the graph and we're going to take a look at the table. Okay, we're going to take a look at the table here, and you'll notice C is given to be 0. If I plug in 0, I'm going to get undefined. And if you looked at the graph, you would see there is nothing right there. There's nothing at 0. Look at that. There's nothing there. But if I start on the left-hand side and I take 0 minus 0.1, I get 0.998. If I go a 100th of a unit to the left, I get 0.9999. Wow. If I go a 1,000th of a unit to the left, I get 99999. Wow, this is getting really close to what number? It looks to me like it's getting really close to 1. So again, what we talk about is we're going to discuss the limit as x approaches 0 from the left for sine of x over x. It seems to me that that equals 0. I apologize. I should say that equals 1. Again, this is the left-hand limit. Now, we are also going to discuss the limit as x approaches 0 from the right-hand side of sine of x over x. This is called the right-hand limit. We're going to go back to that graph and we're going to look at the same thing, or go back to the table. We're going to go a 1/10 of a unit to the right here. Comes out 0.99. That's really close to 1. If I go 100th of a unit away to the right, it comes out really close to 1, even closer to 1. If I go 0.001 to the right, this number is really close to 1. In fact, all the numbers on the left are the same as all the numbers on the right. It seems to me like looking at my table, both sides approach 1, and if these two are equal, we can go find the limit as x approaches 0, the two-sided limit. It seems to me like this is going to be 1. Okay? Now, take a look at the graph. If I approach 0 from the left-hand side, take a look at those y values. Would all of you agree they're getting closer and closer and closer to 1? Same thing on the right-hand side. If I approach 0 from the right-hand side, it looks to me like all of those y values are getting closer and closer and closer to 1. So it kind of confirms, doesn't kind of confirm, it does confirm what we did here in the table. The left-hand limit approaches 1, the right-hand limit approaches 1, and the two-sided limit approaches 1. The second function we're going to look at is the limit as x approaches 0 again of 1 minus cosine of x over x. Now, if I plug in 0 to this, I'm going to get 1 minus cosine of 0 over 0. Well, what is cosine of 0? Cosine of 0 is 1. This comes out to be 0 over 0 as well. Again, an indeterminate form. So what we're going to do is we're going to take, again, the limit as x approaches 0 of 1 minus cosine of x all over x, but we're going to do it from the left. Again, we're going to do a left-hand limit from the graph in the table. We are also going to take a look at the limit as x approaches 0 from the right-hand side of 1 minus cosine of x over x. And again, earlier we called that a right-hand limit. Now here's the graph. Look at your table. If I approach c equals 0 from the left-hand side, 0.1 to the left, it gives me 0.044499. 0.01 to the left, it added a 0 in there. And notice it's got -5 times 10 to the -4. That means 0.000. And you want to bet it's 4999 with more nines? It is. So as you approach 0 from the left-hand side, you can tell all those y values are approaching 0. Let's zoom in a little bit. We can look at those numbers that we just found from our table. There's 1/10 of a unit to the left, 1/100th of a unit to the left, 1/1000th of a unit from the left. Those are definitely approaching 0 from the left-hand side. Now, if you look at the right-hand side, right here, 0 plus 0.1, I get 0.049. 0 plus 0.01, I get 0.0049. 0.001 to the right. Here are those points on the graph. They're getting closer and closer and closer to 0 as well. So what we have here, we have the limit from the right-hand side was 0. We had the limit from the left-hand side was 0. So guess what the two-sided limit is? The limit as x approaches 0 of 1 minus cosine of x over x. That's going to be 0. And that's important that you remember exactly what those limits are. Those come in very handy, and I'll show that in another video later on, why and how we can use those limits. Now, the third limit that we kind of came up with in my class was tangent of x over x. If you graph that and you look at 0, it seems to me from the left, all of these values for y, as my x value gets closer and closer to 0, they look like they're approaching 1. Same thing from the right-hand side. It looks like these y values, as you get closer and closer to 0 for x, those y values are approaching 1. And we can zoom in and we can take a look at the values from the table. If you go from the left, this is the first value in the table, the second value in the table, and right there is the third value in the table. Start from the bottom. This is the bottom value in the table, second one at the bottom, third one from the bottom. It's kind of hard to see all of those, but you can tell they're all approaching 1 from the left and from the right. So we have one more limit we can talk about, the limit as x approaches 0 of tangent of x over x, that also equals 1. Now this is one that can be easily proven. How so? Well, give me another way to write tangent. Tangent is sine of x divided by cosine of x. If you've ever taken a trig class, you know that. I ask people all the time, how's tangent defined? And they say it's sine of x over cosine of x. Well, now what we're going to do is we're going to take the top, which is sine of x over cosine of x, and we're going to multiply it by the reciprocal of the bottom, which is 1 over x. I can rewrite this. And again, I haven't applied the limit yet, so I'm still writing the limit notation. This would be sine of x, and the bottom would be x times cosine of x. Now, when you take a look at this, I can split this into two limits. The rules for limits say if you multiply functions, you can multiply their limits. So if you look closely here, there is a limit right there that I recognize. That's sine of x over x. But what about the cosine? The cosine, it's still on the bottom. But what's the limit here? The limit of the red is 1. And what's cosine? Well, cosine of 0, that's actually 1 as well. So this would be 1 times 1 over 1. The limit is 1. So you notice that's a limit that we can prove using one of our other limit formulas that we proved today from the graph and from the table. I hope this helps with some trig and limits. I'd appreciate it if you guys liked this video to hit the like button, maybe even hit the subscribe button. I would really appreciate that. I'll be posting more videos soon.